Do you hear me?
Yes, sir.
Okay. So what topics we discussed in last class? Before that, good morning to everybody.
Good morning, sir.
Good morning. Good morning, Bob. Right. Good morning. So in last class, we discussed about, I believe that we completed that open system interconnection model, and I gave some assignments to you related to the TCP IP network edge and internet. Yes, sir.
Yes, sir.
So how can we represent data in data link layer? I'll give three options: messages, packets, frames. How can we represent data in data link layer? This is the question. Options are packets, frames, messages. What is the answer? See, you missed my point. In network layer, we can represent as packets. In data link layer, we represent as frames. Don't forget it. In case of physical layer, we represent as bits. Physical layer, bits. Data link layer, frames, frame. Network layer, packets. Transport layer, protocol data unit, TPDU. Transport layer, protocol data unit. In session layer, SPDU. Session layer, protocol data unit. And presentation layer, presentation protocol data unit. Application layer, user data, actual messages. Protocol data unit is it's a type of message only, but added control information in different layers are different. So don't forget it. Please remember those things. And today, I'm sharing my screen. My screen is visible to you?
Yes, sir.
Right. Right. So today we will discuss about network devices. What is the purpose of network device? So here I am expecting good interaction. Be ready with that one. So I will take two students here. I want to say I can take Lakshman and Shirish. Lakshman and so we just imagine that we all are in a same classroom, in a single classroom, physical classroom. So I start my teaching from this side. Here, row 1 students, row 2, row 3, row 4, row 5, row 6, row 7, row 8, row 9, and row 10. So at row 10, Shirish is sitting. At row 5, Lakshman is sitting. Lakshman. Right? And my voice capabilities, for example, do you hear my voice, everybody?
Sir.
Yes.
Right. So when I want to call, I want to send a message, I want to call Shirish. Dear Shirish, what is your roll number? This is my question. I want to ask a question to Shirish. Dear Shirish, what is your roll number? But my voice is reachable to up to 5 inches only, up to 5 rows only. So in this context, whether my actual data is reached to Shirish?
No, sir.
No. So then I use Lakshman. I send this my question. What is your roll number, dear Shirish? I send that question to Lakshman. Then Lakshman regenerate or repeat the same question again to Sirish. And here we have a 5 rows. So here Lakshman is act as a repeater. Now tell me, what is the purpose of repeater? In general, when we are transmitting your data through phone calls or connectionless or connection-oriented, any combinations, coaxial cables, many things are there. During the journey, when distance are more, automatically the voice quality reduces due to coupling effect or due to heating issues or due to garbling information. Many reasons are there. We will discuss all those reasons in the next coming sessions. But whatever the reason, we lost our signal at that particular point of time to reach my original message, my original voice, and my original content to the required destination, intended receiver by repeating. So that means, for example, we want to transmit our message from source to destination of 1 kilometer. But the transmission media capacities or the source capacities, it can reach up to 500 meters only. Then here I installed a repeater. The repeater take my message and regenerate it to this original signal. At the starting point of time, what is the signal strength? It creates the same signal strength and send it to the destination. Do you understand what is repeater is? Yes, please. Do you understand? Right. Now see, read the point. I request all the students, take some 30 seconds of time or 1 minute of time and read the statement. Then we will go to the next device. So now tell me whether network devices are compulsory or not. For our regular transmission of data, for effective data communications, for network performance, can we need network devices or not? So in our real life, do you know any devices related to network? I'm asking you the same question. Do you have any, in practical life, anybody see you any network device? Your home router? Yes or no?
Yes, sir.
In our lab, there is a switch. You know about hub? It's a device. Bridge, it's a device. Gateway, it is also per type. So let us see in this today's session, we will discuss all those network devices and how, because when we want to sending a message from sender to receiver, these two are called edge devices, or actual sender, actual receiver. And whatever the intermediate devices, all these called communicating devices. These communicating devices is a part of network devices. It may be a repeater, it may be a switch, it may be a router, it may be a gateway, many combinations are there. So as of now, any doubts? As of now, any doubts?
No, sir.
See, simple thing, when the signal becomes weak, they copy the signal bit by bit and regenerate it at the original strength. It is a two-port device. Two-port means source and destination. It accepts the signal from the source, this particular repeater, so input port, and repeater regenerate the signal, and through output port, it's sent to the destination. So two-port, input port and output port, two-port device. Next thing, what is hub? Hub is basically a multi-port repeater. Multi-port means what? So in previous example, we discussed about the communication happened between only one source and one destination. But in real time, the thing is not like that. If you are taking a multi-point connection, so what is multi-point connection? What is multi-point connection? I'm expecting answer. How many types of links are there? Point to point and multi-point.
Multi-point.
Point-to-point means a dedicated link existing between two devices only. Multi-point means more than two devices sharing the same link. So in this case, I have a source 1, source 2, source 3, and destination 1, destination 2, destination 3. So here I want to regenerate my signal for all these three users and send the same signal, individual signals to all the destination devices. In this particular context, whether repeater is sufficient our requirement, a single repeater. Yes, please. Okay, if you are not interested, I complete my class. Here I am providing the hub. This hub contains multi-port. For three devices, I am using 3 ports. For destination, 3 ports. So this particular concept is repeater 1, and this is act as a repeater 2, and this is act as a repeater 3. So to buy one repeater, maybe it costs 100 rupees. So when I want to buy 3 repeaters, it will cost, for example, 300 rupees. But when you go with hub, it will available for 200 rupees only. Which one is best? Going with 3 repeaters, and for these 3 repeaters, again, installation cost is high. Installation cost for 3 individual repeaters. Just for example, if you want to fix a fan in your home, for one fan, they usually charge 200 rupees. If they have 3 fans, they usually charge 600 rupees. In the same way, if you go with hub, it is a single device and it can do the task will done by the 3 repeaters at a time. So which one is your preferable? 3 repeaters with the 3 installations, or 1 hub, 1 installation?
One hub.
Hub.
That's it. That's it. Now, what is the point of, see here, and hub connects multiple wires coming from different branches. For example, the connector in star topology, which connects different stages. So I'll explain what is star topology. Star means here, for example, a hub is connected like this. A star way for device 1, for device 2, for device 3, for device 4, which connects different stations. Hubs cannot filter data. What does it mean? So this point is directly related to our network plan, our information importance. Do you remember these two concepts? Network plan and information importance. Network plan means when I want to send a message, that message should be sent to intended persons only. I mean to say, I'll take one example here. So this time, Pranay and Janakeswar. So device 1 owned by Pranay. And here hub is act as Janakeswar. And here D4, maybe Pranay have, for example, some girlfriend. So Pranay want to send a message to his girlfriend through this hub. So it is a private message, right? The conversation between those two are private, we assume it to be. But this idiot, just for fun, because hub cannot filter data, right? So he sent a private message to hub. He sent this message to device 3, that is a Pranay dad, device 2, that girlfriend dad, and girlfriend also. So is it making sense? Whether hub is good?
No.
No, very dangerous, right? These such type of things are, we won't encourage those things. Very dangerous. That is called filter data. And collision domain means once the data, that particular private data leaked to dad 1, dad 2, and followed by girlfriend, almost collision, quarrel, fight with each other, right? That is one point of time. So in other words, hubs cannot filter data, so data packets are sent to all connected devices. Hope you understand this point. In other words, collision domains of all hosts connected through hub remains one. What is collision domain means? Same context, I take hub and device 1, device 2, device 3, and device 4. So in case 1, device 1 plan to send data to device 2. In the same time, device 2 also send data to device 1. At the same time, device 3 want to send data to D4. At the same time, D4 want to send the data to. So at a time transmitting with each other. At a time transmitting with this, it is exactly equal to in multiple 60 students. If we are talking with each other continuously, I don't know for which person I need to send data, for which person I need to regenerate the signal. So multiple incomes, multiple outputs at a single time, which leads to collision. That is that we can assume that the data should be damaged. Do you understand this point? Do you understand this?
Yes, sir.
Right. And what is bridge? So a bridge operates at data link layer. So when I say this point, which address will take care by data link layer? My question. Which type of address will take care by data link layer? Options: process address, network address, device address. See, you are not reading anything. If you really know the answer, it is post in chat box. Other will know. Network address. So you are not following my class. Sorry, dear. And what is the purpose of network layer? Device address. Exactly. Data link layer. Again, I'm telling you, data link layer will take care about the actual device address. Network layer will take care about the network connection between device 1 and device 2, that network address, IP address. And transport layer will take care about which process will take care about your task in that particular device. Explain many times. See, if you are not understanding these concepts, also never understand to you, right? So data link layer will take care about device address. Indirectly managing is MAC address. MAC address. Just imagine, I take the same concept which we discussed already: device 1, device 2, device 3, and device 4. In the place of hub, I replace with the bridge, same D1, same D4, and this time I will take one more person, Sushant and Pranay. Sushant and bridges act as Pranay. And so, do you hear me?
Yes, sir.
Yeah. So in this case, Sushant tried to send a message to his friend. For example, I can say that for more interactive, because we are an online class, that's why I using this example. Please don't mind. So Sushant, please don't mind. Are you there? Sushant?
Yes, sir.
Okay. Yeah. So he tried to send a message to his girlfriend, and but the distance between D1 D4 is very high, and there might be a chance of loss of signal and everything. So he requested the bridge. That bridge is Pranay. So Pranay is very intelligent because bridge operates at data link layer. Pranay is a part of data link layer. Then Pranay knows what is the device address of, what is the mobile number of, or what is the specific device address of the GF, and what is the specific address of Sushant. Then he act intelligently and take this message and send it to the intended D4 device only according to the data link layer MAC address. So now tell me, which one is comfortable, hub or bridge for effective private data communication? Hub or bridge?
Hub, sir.
Hub or bridge?
Bridge, sir.
Bridges.
Bridge. Someone said that hub. The follow on class. If I want to complete the task, it is a 2 minutes of task for me. I don't even explain these things. But the real knowledge, real concept depend upon fundamentals only, not applications. Hope you understand that, right? So see here, a bridge operates a data link layer. A bridge is a repeater. It is also act as a repeater with add-on the functionality that is called filtering content by reading the MAC addresses of specific source and specific destination, and the communication establishing between those two devices only, but not all the other devices which are connected to bridge. That is the main difference between hub and bridge. Do you understand my point? Right. So it is also used for interconnecting two LANs working on the same protocol. It has a single input and single output port, thus making it to two-port devices. Bridges, two-port devices. Now, what is switch? A switch is a multi-port bridge. Multi-port bridge means, what is the advantage of bridge? It can
MAC address.
send data to intended user only. Intended means whatever the things for which person we want to send a message, it can send to that particular device only, that particular person only, but not others. And the added advantage of, but what is the advantage of switch? For example, I take the same example, device 1, device 2, device 3, device 4, and in the place of bridge, I replace with switch, for example. So, device 1 try to transmit a particular data to device 4, but during transmission, due to power loss or due to some other problems, actual message you want to send to is 110.110.100.110. But during transmission, this particular data is corrupted. And switch receives this particular data, this particular frame from device 1 to switch, and here switch applying some error detection correction methods on this particular frame. If this frame is corrupted, if the frame is damaged, then switch stops transmission of damaged packets to the destination, whether it is advantage or disadvantage. Advantage is right, because in this particular scenario, this entire packet is lost or that particular frame was damaged. So what is the purpose of sending damaged package? What is the purpose of sending damaged package through this network? That means, just imagine if device 1, device 2, device 3, and it is a server, for example. So device 1, device 2, device 3, here we have a switch. So device 1 sending frame 1, device 2 sending frame 2, frame 3. So switch take all these frames and at a time it can put into a single channel. This is called multi-port. That means a particular channel, this particular link is utilized by 3 devices in the form of frame 1, frame 2, frame 3. So in this case, frame 1 is damaged. Then switch, just imagine, if switch is not there, this entire channel is utilized by frame 1, frame 2, frame 3. That means frame 1 is also taking some bandwidth, right? Frame 1 is also utilizing this network or not? Frame 1 is also utilizing this network or not? For example, the capacity of that particular channel is 4 Mbps or 3 Mbps. the capacity of the channel. Then this particular channel, 3 frames are transmitted. So then this channel is shared with 1 Mbps data frame 1 Mbps data frame 2, 1 Mbps data frame 3. If frame 1 is corrupted, if switch is established here, then it stops the frame 1. Then this entire 1 MB is allocated to 0.5 MB, 0.5 MB. I mean to say this 3 Mbps data. This 3 Mbps data, frame 1 is stopped here. Those entire 3 Mbps data will shared by these 2 frames only, and they're receiving very fast. So whether it is advantages or disadvantages. Are you understanding the scenario? Advantages, right? That is the advantage of switch case. If you take this is a bridge, this is a bridge. For practical example, I will show you one thing, bridge. This bridge is connected to device 1, device 2, device 3, device 4, and so on, device 10. So it doesn't having filtering, bridge doesn't take care about whether frame is damaged or not, whether the data is damaged or not, whether it is damaged or not damaged, simply sending all those packets to the destination. In D1 to D10, D2 is failed, D3 is failed, and D4 is failed, and D5 is also failed. I can say that D2, D3, D4, D5 having bad frames or bad data. So this entire network, all these 10 devices sending all the 10 frames. So when the number of users increases on the network, performance is increasing or decreasing? Decreasing, right? Anyways, if decreasing, if all these 10 frames are good, then well and good, we can accept that one. But among those 10 frames, 4 frames are already damaged. 4 frames are already damaged, then what's the purpose of sending those things? So in this particular context, bridge is good or switch is good?
Bridge.
So
Bridge doesn't filter data. Bridge doesn't take care about damaged frames. Bridge, whether input frames, whatever the frames are coming to bridge, whatever the data is coming towards the bridge, whether the data is damaged or not, it doesn't care. It simply take the data and send it to the transmission medium, send it to the link. Switch, whatever the packets are received by the switch, whatever the frames are received by the switch, it can perform error detection correction methods and verifying all the data, those data packets which are efficient and good. Those good packets only allowed by the switch to transmit to the next station. Which one is good, bridge or switch? Come again?
Switch.
Then listen carefully. Every time you people telling the wrong answer solely. Anyways, appreciate that wrong answer also. At least you are replied. Right. So switch, you can take a look of it. So here a switch is a multi-port bridge with a buffer. What is the purpose of buffer here? What is buffer? It is a temporary memory allocation, right? It is a temporary memory allocation. So when multiple data packets are received by switch, first it store it in this buffer, and performing error detection correction methods. Once the error detection correction method is completed, then forward to next network if it is good, or discard it or terminate it if it is a bad frame. That's why we're using buffer, temporary buffer. So a large number of ports simply less traffic and performance. A switch is a data link layer device. The switch can perform error checking before forwarding data. That makes it very efficient, and it does not forward packets that have errors and forward good packets selectively to correct port only. In other words, switch divides collision domain of hosts. Collision domain of hosts. Collision domain means divides means those packets which are not good, it doesn't allow it. It doesn't allow it. Those packets which are good, it allowing those things only. Due to that, we can reduce the collisions also. Hope you understand this. Are any doubts?
Thanks.
Right. And next point, router. So what is the purpose of router? A router is a device like a switch that routes data packets based on the IP address. Because switch is a bridge, and bridge working on data link layer, and bridge having MAC address only. MAC or device address only. So when we have a device address, at most we can communicate. At most we can communicate. We are inside the network. We are inside the network one. And there is some other existing network too. So here device 1, device 2, device 3. Here device 4, device 5. So to establish a communication between device 1 and device 3, here I just need this device 1 address and device 3 address. But when we want to establish a connection between device 2 and device 4, these two are not part of same network. At that particular time, I need where device 2 existing, network 1. Where device 4 existing, network 2. So I need these two addresses also. These two addresses will take care by router. These device 2, device 3 addresses are taken care by switch. You understand the difference?
Yes.
Right. So a router is a device like a switch that routes data packets based on the IP addresses. Router is mainly a network layer device. Switch is data link layer device. Routers normally connects LAN and WANs together and have a dynamically updating routing table. What is dynamically updating? That means when we have a source device and when we have a destination device and we are sending the packets through router 1 and router 1 connected to router 2 and router 3. Multiple routers are there in real life. Router 4 and router 2 connected to router 5 and router 6 and router 5 connected to this one and this one and this one and for example router 9. In this context, sender have a packet 1. Packet 1 send it to router 1 and router 1 ask R2, dear R2, if you're free, I will send packet 1. Then R2 reply back, I am busy. So that's okay. Then I change my direction to R3 dynamically. R3. Source having packet 1 and packet 2, for example, first packet 1, router 2 is busy at that particular time. Then I send this packet 1 to router 3. Then transmitted like this way. And next packet 2 is transmitted to router 1 again. And router 1 this time asks router 2, are you busy? Now in this particular situation, router 2 is free. Then I send packet 2 in this direction. So according to the convenience, router 1 and 2, 3, 4 communicating with each other according to their busyness, according to their ideal waiting time or ideal time, they will switch with each other. They switch dynamically. If it is available, follow that path. If it is not available, don't wait. Don't waste your time. Go for the next process. Go for the next order. If it is also busy, go for the next. If it is also busy, come back and again ask router 2. This is continuously updating, and in this particular context of time, which router is available, which communication device is available, we can utilize that one and we can send our packets through that network. You understand this?
Yes.
Right. And what is gateway? A gateway, as the name suggests, is a passage to connect two networks together that may work upon different network models. As of now, whether it is a switch, router, for example, this particular device combination, these two are following OSI model only. That means whatever the protocol supported by device 1, whatever the protocol supported by device 2, all are same because all are belongs to same network model. But we have another thing, it's following maybe TCP/IP model. Then the protocols and the individual responsibilities of multiple layers of TCP/IP is not equal to the individual responsibilities of multiple layers of OSI model. In this particular context, router fails. Router is working on same technology, same topology, and same protocol only. But here we can replace with the gateway. Gateway act as a protocol converter. Protocol converter. That means it converting this entire network model into the gateway format. And again, this converting this gateway format into TCP/IP format. That is the advantage of gateway. You can take up. They basically work as the messenger agents and take data from one system, one type of model, interpret it, that means convert it and transfer it to the another system. Gateways are also called protocol converters and can operate at any network layer. Gateways are generally more complex than switch and router. Do you understand this? Do you understand what is the purpose of gateway? Right. Browser, C. So in traditional days, they are using individual devices only, but when evolution starts, then they mix up multiple features and they can go with the hybrid combinations of hybrid devices. Here B means bridge, router means router, bridge and router. Bridge will take care about device addresses, router will take care about network addresses. So it can act as both the things. To buy bridge and router individually, it may cost 10K, but if you have router, it will get for 5K or $5,000, which is cheap and best, right? So it is also known as bridging router. Is a device which combines the features of bridge and router. It can work either at data link layer or at network layer. Working as a router is capable of routing packets across networks, and working as a bridge, it is capable of filtering local area network traffic. So whatever the features were explained in bridge and router, those two features, the combination of features are already applicable to router also. So any doubts?
No, sir.
Right. Okay. So I will ask you some quick questions. What is the difference between switch and router? What is the difference between switch and router? Yes, Vishnu.
Switch sends the data by error detection and error corrections.
Yeah. So
Whereas router sends the data based on IP addresses.
Yeah. Router specifically used for connecting LANs, WANs, and MANs. But switch is limited to local area networks only, multiple local area networks only. But recent days, some hybrid switches are act as a routers also. But in traditional days, the meaning of switch is completely different. But recent days, they are updating multiple features. And what is the difference between repeater and hub?
So
Repeater and hub. Yes,
hub
Shreya?
is a multi-port repeater, sir. While repeater just regenerates the signal, hub actually sends it. It uses broadcast mechanism, so it sends it to different devices.
Perfect, perfect. Anyways, I will share this document by in Moodle box. All of you get access to Moodle?
Yes.
Okay, right. So please revise the topics every time, but don't lose our interest. Next one. Now we relate all these things to. Now we relate all these things to topologies. Here. So here we have different types of topologies. What is network topology? Network topology means, so for example, I have a sender and I have a receiver. These two are 1 kilometer distance, but at most sender can send his data up to 500 meters. At the point of 500 meters, the signal generated by the sender will lost. At the point of 500 meters, the signal generated, whatever the signal sent by sender, whatever the data sent by sender, by degrading that performance at the 500 meters, the entire this entire signal was lost. Then is it possible to send this data to receiver?
No, sir.
So in this particular point, what device we need to use here? What is the suitable device we need to use here to send my entire data to the receiver with the same signal range, with the same signal strength? Repeater.
Repeater, sir.
Exactly. Fantastic. Repeater. For example, you have a multiple sources here and multiple receivers are here, and all these sources using the same thing. At this particular time, I need multiple input ports, multiple output ports, and these three, they don't want to lose their signals also. Here we have a 3 ports. In this particular context, what is the suitable device we are using here? Hub. Yes, sir. So here, in this case, my third scenario is sender 1 sends data to device 3, receiver 3. So the data should be transmitted between sender 1 and R3 only, but not all the others. The limitation of hub is it can send data packets to everybody. In this particular case, what is the suitable device? Yeah, what is a suitable device? Sender 1 need to send data to R3 only, but not all the others. Bridge. Right. So again, in this particular case, I want to verify whether all these packet data is damaged or not, good or bad. And I want to transmit good packets only. I want to stop bad packets. What is a suitable device?
Switch, sir.
Switch. And all these multiple devices belongs to one local area network. All this belongs to some wide area network. I want to communicate these local area network devices to wide area network devices. In this particular context, what device I need?
Router, sir.
Router. And this entire system is following network model 1. This entire system following network model 2. So these protocols are different and these protocols are different. I need a protocol converter. What is a suitable device?
Gateway.
Gateway. So on these, so how can we organize all these things? Is called a topology. Topology means the arrangement of a network which comprises of nodes and connecting lines via sender and receiver is referred as network topology. Network topology, for example, mesh topology. Mesh means, according to mesh topology, every device is connected to every other device. Every device is connected to every other device. For example, device 1 and device 2. So how many connections I need? If you take device 1 and device 2 and device 3, every device should be connected directly to device 2 and 2 and 2. If you take D1 and D2 and D3 and D4, every device should be connected to device 2, device 3, device 4 and so on. That means there should be a dedicated link existing between direct devices. That is called mesh topology. Mesh means connecting every device to every other device. Then what is the advantage here? What is the advantage? What is the disadvantage?
Sir, advantage maybe if there is a error in one network, it will go to another.
Excellent. Excellent. For example, this connection fails, then there is a very less chance of loss of data. I go with this direction. Yes, sir. Yeah, too many ways. Insulation, because establishing connection between D1, D2, this link and this link and this link, many things. So, for example, in this context, I can say that if n equal to 2 devices, how many links I need? When we have 2 devices, how many links I need in mesh topology? How many links?
1, sir.
1. When n equal to 3, how many links?
3, sir.
3. When n equal to 4, how many links?
6, sir.
6. When n equal to 5, how many links? See, here I can use a trial and error method n into n minus 1 by 2, for example. So when n equal to 2, replace this 2 here. 2 into 1 by 2, how much? 1. And 3 into 2 by 2, 3. And 4 here, 4 into 3 by 2, 6. Now tell me for 5.
10, sir.
10, right? Yes or no? So can I say that? So when maybe in gate questions or some other component exams, they will might be asking about these things. How many number of links required for connecting 10 devices by using mesh topology? How many links you need for 10 devices? Yeah, 10 into 9 by 2, how much it is?
45.
45.
That's it, 45, right? 45 connections. But here, if I go with simplex, if this link is duplex, how many devices I need? For example, if link is duplex and the link is simplex, that means to say, this point is very important, listen carefully. So we have two devices, device 1 and device 2. What is simplex?
Communication in only one side.
One direction. So here, if the link is simplex, how many links needed to connecting D1, D2 for effective data communication from D1 to D2 and D2 to D1 also, reverse also. If I'm establishing simplex, then this is a simplex line. So D1 is able to send data to D2, but reverse is not possible. Now tell me, for effective data communication, how many simplex links needed between D1 and D2 for applying mesh topology? 2 links, right? 2 simplex links. Yes or no?
Yes, sir.
So when n equal to 2, the simplex links are 2. In the same way, if we go with 3 devices, how many total number of simplex links I needed?
6, sir.
6. 6. For n equal to 4?
All have
Well.
batteries.
N equal to 4.
12, sir.
1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 12. So can I say that it is 2 into n minus 1 by 2? Yes or no?
Yes, sir.
Then 2 to cancel, it is n into n minus 1. Now the question is, for establishing a mesh topology for 100 devices, if all I'm having simplex links only, I don't have any duplex links, then how many total number of links I need for 100 devices? To establish a fully mesh topology, how many total number of simplex links I need to connecting 100 devices?
9,900.
That's it. That's it. Into 99. For if you are supporting full duplex, by 2, right? So this is something about mesh topology here. In mesh topology, every device is connected to another device via channel. Of course, here I mentioned all the things, all the points also. Take a look of it. And what is the advantage? It is robust. Robust means there is very less chance of loss of data, and fault is diagnosed easily, because if connection is failed, no need to bother about it. But what is the problem? Installation and configuration is difficult. Cost of maintenance is very high. As discussed, the same point, star topology, we already explained. Here we have a sum hub, and if system 2 having any fault, there is no bother of this communicating device. If system 2 or this connection may be failed, there is no problem. All these 3 systems are communicating efficiently. But if hub is failed, the entire network collapse. Yes, sir.
Yes.
Right. This is something about star topology and bus topology. Bus topology means it maintaining a single backbone coaxial cable that is called multi-port. Multi-port. Multi-port means shareable link. This link is shared by multiple devices. The same link is shared by multiple devices. In this particular context, what is we need is a repeater, because from device 1, I want to send a data. This link is shared by multiple people, so there might be a chance of loss of signal. That's why for every 50 kilometers, 60 kilometers, I establish a repeater 1 and repeater 2 and repeater 3. So these repeaters again regenerate the signal to original strength and send it to the intended devices or destinations. So the disadvantage of bus topology is if the central backbone, this particular backbone is failed, all network collapse. There is no effective data communication, but installation is very easy. Here, because by using a single channel or by using single multi-port network, multiple devices are connecting easy. This particular topology is flexible for us, comfortable for low-scale organizations. It's a couple of 50 or 60 employees. We will do that one. And ring topology like this. Ring topology. So here I'm maintaining a token. So this token contains address of a particular device. During the transmission of data, this device sending this data to this particular device, and a token contains, for example, device name is some X, Y, Z, and L. So X want to send a message to L, then X take the token and mention L there. So during the transmission of data, this token asking whether URL, no, whether URL, no, whether URL, yes, then take it. And the disadvantage of this particular ring topology is if this connection breaks, then this entire problem, this entire network also collapses like this. So here we can use dual queue, dual ring, one for clockwise direction, one for anti-clockwise direction. If outer ring fails, inner ring works. If inner ring fails, outer ring works. In this way, we can communicate the data via ring topology. And tree topology, we have a central hub and a secondary hub and secondary hub. We are maintaining the 3 different types of hubs here. So if this entire hub is fails, then this system all lost. And next one is hybrid topology. It is a combination of mesh topology and ring topology and star topology. It is your wish. In latest trends and nowadays, many people are going with this hybrid topology only. They can use mix up many things. So this is something about your topologies. And here I mentioned, I already assigned some what we called assignment topics to you. Here I mentioned the overview of the basic in our point of view, in my point of view. I can collect some data related to internet. How can they represent internet like this way? And what is that internet today? And what is TCP/IP model? What is the difference between protocols and OSI model? And what is the clear difference between TCP/IP and OSI model and everything? And transmission media, that is connection oriented and connectionless. Again, connection oriented maybe a coaxial cable. It is a high capacity fiber cable, some more high capacity, twisted pair, maybe less capacity. According to organization size, we can decide which network or which type of guided medium we need to use. And unguided waves means it is a radio waves or microwaves, infrared waves, many combinations are there here. So LAN, WAN, here I mentioned all things, local area networks. What is WAN, what is a comparison of different types of wireless networks and wired networks. I will share this PPT, take a look of it. If you have any doubts, you can reach me. As of now, any doubts?
Yes.
Right? So if no doubts, so every class, I will ask some questions to you for your just remembrance purpose only, for what we call brush up the topics. And if no doubts, we will wind up the session. Shall we?
No doubt.
Yeah, because I'm not getting much time here to explain everything. So when I ask you some questions, you are not able to answer those things. Again, I'm explaining the same topic. Yeah, thank you all. We will meet tomorrow's class with some other concepts. Tomorrow we will discuss about switching concepts, different types of switching concepts. Thank you.
Okay.